Hey everybody, what's up? Welcome to this video. In today's video, we're going to learn about basic concepts in R programming language. So here is my first example. We're going to learn how to declare and use variables in R. So first of all, we need to be familiar with the assignment operator. So this is the assignment operator, which is this one. So when I want to assign a number to a variable, I use the assignment operator as you see it here. Okay. So this line of code means that X gets the value 10, or we can say number 10 is assigned to the variable X. So this is basically how we can assign a number to a variable in R. Then in the next line, we are having the assignment of number 5 to a variable y. So y equals 5 or y gets 5. So this is how we are assigning number 5 to a variable called y. Then in the next line, we are adding x and y and storing it in a variable called z. So x is 10. Y is 5, so we are adding them together. So 10 plus 5, it will be 15, and 15 is assigned to a variable called z. And finally, in the output, we are printing the value of the variable z using the print function. So we use the print function, and in parentheses, we write down the name of the variable we would like to be printed. So when I run this code, this is why I see number 15 in the output, because 15 is the output of x plus y, which was initially assigned to a variable z. But if I want to have something more than this, so I could have a variable, for example, x1, and number 12 is assigned to it. I can have the variable x2 and number, for example, 8 is assigned to it, and I have a variable called x3 and x1 minus x2 is assigned to it. And finally, I would like to print the variable x3 in the output. So when I run this code, I see that there is a mistake here. Sorry. So yeah, the assignment operator was not written correctly. So I run the code one more time and I see number 4 in the output. This number 4 comes from the fact that number 12 is assigned to a variable x1 and number 8 is assigned to a variable x2, and we are having x1 minus x2, meaning that 12 minus 8, which is number 4, is assigned to variable x3. And then we are printing the variable x3 in the output, which is this number 4 in the output. So basically, this is how we can have the declaration and using variables in R. Thanks for watching. Hello everybody and welcome to this video. In today's video, we're going to discuss different variable types in R. So we are having the string variable, we are having numeric variables like integers, we are having double or float variables, and also we are having Boolean variables. So let's start with the string variable. In order to declare a string variable, we are going to use quotes. And inside quotes, we are going to write whatever we want to be as our string. It can be a name, it can be a phrase, it can be a sentence, whatever. So on the right side, we write down the string in quotes. Then we use the assign variable to assign that string to a variable. And on the left side is the name of our variable. So for example, I call this variable name. It can be X, it can be Y, it can be whatever that we choose for it to be, in fact. So this is basically what we choose is going to be our variable. So this is the first string that I have here. I can have the name of the string, which is my string, for example, and I use the assignment operator, and then on the right side I write down Reza Shahin, for example, from our programming language course. Okay, so this is the string that I would like to be assigned to a variable called my string. Okay, so this is how we can have a string variable, we can declare it. Then here I'm having an integer variable called age, and number 25 is assigned to it. So here number 25 is assigned to a variable called age using the assignment operator. Or I can have another variable as well here. So I can have, for example, my age, the assignment operator, and on the right hand side I write down 34, for example, or whatever. It can be x, and then I write down 21. So number 21 is assigned to a variable called x. Then we can have double or float numbers also being assigned. So for example, here you see that 1.68 is assigned to a variable called height. Or I can have my number, then I assign 3.14, or my, for example, I can have x2 here, and I assign a number 6.51, for example, to it. So on the right hand side I write down the number, on the left hand side I write down the name of my variable. Then I have the Boolean variables, or let's say logical variables. These Boolean variables are going to be either true or false, depending on what we are going to assign to them. So they are either true or false. These are the only options that they have. So here on the right side, I assign the true Boolean variable to the variable name is student. So is prof, for example, can be the second Boolean variable, and it is false. Okay, so this is another Boolean variable. So either true or false. On the right side, on the left side, we write down the name of the variable that we want. So if I want to print them here, I use the print function, and then I write down the name of the variable. So name can be there. This is the name of my first variable. Or we can have my string, we can have age, my age, x, height, my number, etc. until the end. So whatever we want to be printed, we write down inside the parentheses. So when we run the code, we are printing first the name variable, which is Alice. So Alice here was assigned to a variable called name. And then we are having it in the output. Then we are printing the age, we are printing the height, which was 1.68, and finally we are printing is the student variable, which was having the true Boolean variable value. So true is being printed in the output. So instead of name, if I add, for example, not instead, let's say I would add another print here, and my string is being printed. So if I run this code, you will see that this string is also being printed, Reza Shahin, from our programming language course. So I was printing it in the output using the print function, and my string is this variable, which was having this string being assigned to it. Okay, so in this video we learned about different variable types. We learned more specifically about strings, integers, doubles, and floats, and we learned about Boolean variables. Thanks for watching. Hello everybody, and welcome to this video. In today's video, we are going to discuss logical variables and Boolean values. Okay, so true and false are the two Boolean values in R that we have. So for example, in order to have a logical variable, we need to assign a Boolean value to it. Okay. So for example, here I am assigning the true Boolean value to a variable which is a logical variable called logical underscore var1. Okay. We can have it to be x, for example, for the sake of simplicity. Let me revise this one also, this one y, and this one y. Okay. So the true Boolean value is being assigned to a variable called x using the assignment operator. Also, the false value is being assigned to y variable, which is y logical variable, using the assignment operator. Okay. And then we try to print x and y. So when we run the code, first of all, we see true in the output, and then we see false in the output, which are representing the values for x and y. So x and y, they are logical variables that they have actually the Boolean values true and false that we assigned here. Thanks for watching. Hello everybody and welcome to this video. In today's video, we are going to talk about basic math operations in R programming language. So I need to first have two variables that I call them A and B. Two numbers are assigned to them, 8 and 3. So number 8 is assigned to variable A using the assignment operator, and number 3 is assigned to variable B using also the assignment operator. So A gets 8 and B gets 3. Now I would like to calculate their sum, subtraction, multiplication, division, and exponentiation, for example, A to the power of B, and to find the remainder of their division. In order to find the addition of these two variables, I have A plus B on the right hand side. Then I have the assignment operator, which is being assigned to a variable called sum. And when I print the sum here in the output using the print function, I see number 11 is being printed in the output. So 8 plus 3, it is 11. 8 plus 3 is 11, is assigned to a variable that is named sum, and then here we are printing that variable, which is here 11. Okay. Then we are having the subtraction, which is A minus B on the right hand side, and the result of this is assigned to a variable called difference. It can be y, it can be x. The name, there is no important, the name is not important, so we can put whatever we want. So I just put difference because it makes more sense. So A minus B, which is 8 minus 3, is assigned to a variable called difference, and the result will be 5. So when I print the difference function, number 5 is being shown in the output. Then I have the multiplication. So A multiplied by B is assigned to a variable called product. And here I use the print function to print product. So 8 multiplied by 3, it will be 24, and we see it here in the output. Then in order to divide them, so A divided by B, meaning that 8 divided by 3, so it is on the right hand side and it is assigned to a variable called division on the left hand side. So I use the print function to print the division, and we see that this is the output and of the 8 divided by 3. Then I have the A to the power of B, meaning that 8 multiplied by 8 multiplied by 8. Okay, so when we are having 8 to the power of 3, it means that we are having 8 multiplied by 8 multiplied by 8, which is number 512. So this is assigned to a variable called power, and we are here printing power in the output, and the number in the output is 512. And finally, we are having the modulo operator. So we want to find the remainder of a variable divided by another variable. If I want to know actually the remainder of A when it is divided by B, I use the modulo operator, which is this one. Okay, so the percentage sign 2 times is being there. So A modulus operator, and then B is going to be assigned to a variable called modulus. Okay, and we are printing modulus in the output, so the remainder of A divided by B is number 2 that we are having it here in the output. So basic math operations we learned in this video, how to have the declaration of 2 variables A and B. So 2 numbers are assigned to A and B. We learned about basic math operations, namely addition, subtraction, multiplication, division, exponentiation, and finding the remainder using the modulus operator. And then we learned how to print them in the output. Thanks for watching. Hello everybody, and welcome to this video. In today's video, we're going to learn about logical comparison in R programming language. So here, first of all, we are having 2 variables called A and B. So number 10 is assigned to variable A, number 5 is assigned to variable B here. Now we would like to have a logical comparison. So first of all, we would like to have the comparison of A and B. More specifically, we would like to check if A is greater than B or not. So if this statement is true, meaning that A is indeed greater than B, the Boolean variable true, which is this one, is assigned to the variable on the left-hand side comparison one. Okay, so this is the assignment operator, and this is the logical comparison. So A is greater than B, which means that 10 is greater than 5. Is it true? Yes. Therefore, true is assigned to comparison of one variable. So when we print comparison one variable, we see that true is being shown here in the output. Then we are having another logical comparison. So we would like to check to see if A equals B. In order to check equality in our programming language, we need to have 2 equal signs to make sure that we are checking the equality. Okay, in order to make sure that you're comparing the equality in R, just remember that you need to have 2 equal signs. Okay, so here I check to see if A equals B, meaning that 10 equals 5. Is it true? No, it's not true. So it's false. So this is false. Therefore, false is assigned using the assignment operator to a variable called comparison2. And when I print comparison2, I see false here in the output. And finally, we are having the not equal sign. In order to check not equality, we need to have these 2 signs, okay? Exclamation mark and the equality sign. So here I'm telling that 10 is not equal to 5. Is it true? Yes, it is true. Therefore, true is assigned to comparison3 variable, and here we are printing this variable, and we see that true is being shown here in the output. Therefore, we see that here in this video we learned how to declare 2 variables, how to have the logical comparison, and how to print their output. But if I change these variables, so now A equals 10 and B equals 50. So if I run the code one more time, this time the results are different. So here we are saying A is greater than B, meaning that 10 is greater than 50. Is it true? No, it's not. Therefore, false is assigned to comparison 1. And when we print comparison 1, we see that false is being shown here in the output. A equals B. Is it true? No, 50 is not equal to 10. So false again is assigned to comparison 2 variable, and comparison 2 variable is being shown in the output as false. And finally, we are checking to see A is not equal to B. Is it true? Yes, because 10 is not equal to 50. So true is assigned to comparison 3 variable, and you see that when we print comparison 3, we see true in the output. Thanks for watching. Hello everybody and welcome to this video. In today's video, we are discussing if conditions in R. So first of all, I have a variable called x. Number 5 is assigned to the variable x. So x gets 5. And we are assigning this number 5 to the variable x using the assignment operator. Now I would like to check something. I would like to check one condition. I would like to check to see if this variable x has a value that is greater than 0. In order to check that, we need to use if conditions, or let's say if statements. In order to implement them in R, we simply write down the if keyword. Inside the parentheses, we are going to have the conditions, meaning that I would like to execute the following if x is greater than 0. So if x is greater than 0, then execute this part. You see the curly braces here? Execute this part. Print x is positive. Okay. So now when I run this code, I see this message. X is positive, meaning that compiler checks the value of the variable x and checks to see if that value, which is 5, is greater than 0. Yes, it is true. Therefore, it enters this part and execute this part of the code, which says x is positive, and we see it here in the output. Now I change the value of variable x. Now 50 is assigned to x. So what do we see here? X is positive. Again, the same thing is being shown. Why? Because 50 is still greater than 0, and this part is being executed. However, if I assign negative 50 to the variable x and I run the code, we see nothing happens in the output. Why? Because we only defined one if condition saying that, okay, do something only if x is greater than 0. We didn't say that, okay, if x is not greater than 0, do something else. This is why we see nothing here in the output. Okay. So basically in this video, we learned how to declare an if condition and check to see if a variable is greater than 0 or not in R. Thanks for watching. Hello everybody and welcome to this video. In today's video, we're going to learn about if conditions. So we're going to discuss if and else conditions in R. So first of all, we would like to have a program to write to see if a number is a positive number or a negative number. Okay. In order to check this, we are having the declaration of variable y, and number -3 is being assigned to this variable y. Okay. So we are having the number -3 being assigned to variable y using the assignment operator. Now I would like to check to see if this number is greater than 0 or not. In order to check that, we need to use if conditions. In order to implement the if conditions, it will be like we would like to execute certain part of the code only if a certain condition is true. And if that condition is not true, we may want to execute another part of the code. Okay. So for example, here, I write down the if keyword, and in parentheses, inside parentheses, I write down y greater than 0, meaning that I would like to check to see if y is greater than 0 or not. So if y is greater than 0, then execute this part of the code. Okay. So if y is greater than 0, print this message. Y is positive. And we are having the else part. Otherwise, if this condition is not true, then execute this part of the code. Okay. So either this part of the code is going to be executed, or this part of the code is going to be executed depending on the value that is assigned to variable y. So when we write down the conditions here, the if conditions inside parentheses, we write down the conditions. We check that, okay, if y is greater than 0, execute this part of the code which says y is positive. So when I run this code, number -3 is assigned to variable y, and the compiler checks to see if -3 is greater than 0. Is it true? No, it's not true. Therefore, this condition is not met. Therefore, this part of the code is not executed. Then compiler goes to the else part, meaning that, okay, do whatever when the above mentioned condition is not true. Okay. So this is why it is printing that y is not positive. It's not a positive number. How do we know that? Because if a number is not greater than 0, therefore it's not a positive number, then it's a negative number. So we print this message. Y is not positive. So what if I change the value that is assigned to variable y? Now this time I would like to assign number 3 to y. So and I run the code one more time. This time it says y is positive. Why? Because 3 is greater than 0, and only this part of the code is being executed. Y is positive. Okay, so remember this. If conditions is inside the if conditions, it is going to execute only one part of the if condition, either this part or the other part or the other part or the other part. If you are having, for example, 10 conditions, it is going to be executing one part of this whole 10 conditions. Okay, so now y is 3, it is greater than 0, it is printing this part, y is positive. If I write down 30, 30 is still greater than 0, therefore y is positive again, is being printed here in the output. But if I write down, for example, -3 and I run the code one more time, we see that y is not positive message is being shown here in the output. Thanks for watching. Hello everybody and welcome to this video. In today's video, we would like to write a program that checks one score, and it is going to see if this score is grade A or grade B or grade C or below. Okay. So first of all, we need to have the score. We are initializing the score variable, and number 75 is being assigned to the variable score. Okay. Now, in order to check if this score is categorized in grade A, B, C, or below, we need to have if conditions. Meaning that, for example, if the score is greater than or equal to 90, it is going to be categorized as grade A. However, if it's greater than or equal to 70, it is going to be labeled as grade B, and otherwise it is grade C or below. Okay, so we need if conditions. So in order to define the if conditions with 2 conditions and one else part, we are having the following. So we use the if keyword. We are having the condition in the parentheses saying that score is greater than or equal to 90. So if this condition is true, execute only this part of the code. Okay. So if this condition, the first one, is true, it is not going to execute any other part of the code. Only this part of the code is going to be executed. So if the score is greater than or equal to 90, print grade A. But if the score is greater than or equal to 70, execute this part of the code, okay? Grade B. And how do we check that? If you want to define a new condition apart from the first one, you need to write down else if, okay? So if you want to define a new condition apart from the first one, you write down else if. So else if the score is greater than or equal to 70, print grade B. And otherwise, meaning that if neither of these two conditions, this score equal greater than 17, score greater than 90, if neither of them is correct, go to the else part, okay, and print this part of the code, grade C or below. Okay, so when I run this code, so 75, is it greater than 90? No, therefore this part of the code is not going to be executed. So 75, is it greater than 70? Yes, it's true, therefore this part of the code is being executed, grade B, okay, and not any other part. So we see that grade B is being shown here in the output. So now if I, instead of having 75, I have 95, and I run the code one more time, I see grade A in the output. Meaning that 95, is it greater than 90? Yes. So print grade A. And that's it. It's not going to execute the blue part anymore. Okay? Because 95 is greater than 90 and the condition is met. So it's not going to execute any other part. However, if instead of 95, I was having like 65 and I run the code one more time, it is going to check 65. Is it greater than 90? No, therefore it's not going to execute this part. 65, is it greater than 70? No, it's not going to execute this part. And finally, it is going to go to the else part because neither of these two conditions were true. So it is going to else part and print grade C or below. Okay, so we see that grade C or below is being shown here in the output. Thanks for watching. Hello everybody and welcome to this video. In today's video, we are going to write a program to check if a number is positive and also an even number, and also it is an even number. Okay, so we know that if a number is called an even number is a number that is divided by 2 and the remainder of this division equals 0. So this is a definition of an even number. So let me write it here for you so it would be easier to understand. Hello everybody and welcome to this video. In today's video, we're going to write a program to check if a number is a positive number and also is an even number. In order to make sure that a number is an even number, we are having the following definition. If a number is divided by 2 and the remainder of this division equals 0, it means that that number is an even number. Otherwise, it's an odd number. So let me write it down here for you. So a number is an even number if that is divided by 2 and the remainder of this division equals 0. Okay, otherwise it is an odd number. So this is the definition of an even number. We would like to check to see if a number is an even number and at the same time it's a positive number, and at the same time is an even number. So in order to do that, to check that, to write that program, we are assigning number 4 to a variable called a, and we are using the assignment operator. Okay, this is the assignment operator to assign number 4 to a variable called a. It could be any name, whatever we want, we can choose it. And then, first of all, we need to check if this number is greater than 0, and then check the condition to see if it's an even number or not. And we need to use if conditions for that. So first of all, we are checking to see if a is greater than 0. If a is greater than 0, meaning that this statement is true, this part of the code is going to be executed. Okay, this part of the code is going to be executed. And inside these if conditions, we are having another if condition that is here. So if a is greater than 0, we entered the first condition, but the second condition is that if a is divided by 2 and the remainder of this division equals 0, it means that not only this number is a positive number, but also an even number. How do we check that? To see if a number is divided by 2, the remainder of that division equals 0. We need to use modulus operator, so the percentage sign 2 times. In order to find the remainder of a division, we need to use the modulus operator. Okay, so a, if it's divided by 2, the remainder of their division is going to be found using the modulus operator is equal to 0, meaning that that number, if this condition is true, meaning that that number is an even number. Therefore, we are going to execute this part of the code which says a is a positive number. Okay, so when I run this code, this is why we are having this message being shown there. Okay, it says a is a positive number. We could have one else part here that is going to write down this message. For example, a is a positive number but not an even number. Okay, so when I run the code, I see the same message, but if I have number 5, I run the code one more time, I see this message. A is a positive number but not an even number. Okay, so what happened here? So a, it is equal to 5. So 5, is it greater than 0? Yes. Therefore, the first condition is true. It is going to execute this part of the code, but not all of this part. Why? Because we are having another if-else condition. So 5 divided by 2 and the remainder of this division, is it equal to 0? No, it's not equal to 0. Therefore, this part of the code is not executed, meaning that that number is not an even number. Therefore, it goes for the else part, meaning that that number is still positive, but not an even number. Therefore, it is going to print this message. A is a positive number, but not an even number. This message is being shown here in the output here. Also, first of all, we check this part. A is positive, and if A is positive, this part is executed. But what if A is not positive? So I write down this condition here. So print A is not a positive number. So I run the code one more time, but this time I have -5. So when I run this code, -5, is it greater than 0? Obviously not. Therefore, this part of the code is not executed. Okay, but this else part is executed, meaning that it is going to print A is not a positive number. So in this video, we learned about if conditions more in depth. In particular, we learned how to have nested if conditions, meaning that one if condition inside another if condition. Okay, this is what we call nested if conditions. We learned about them and we checked to see if a number is a positive number and at the same time is an even number or not. Thanks for watching. Hello everybody and welcome to this video. Hello everybody and welcome to this video. In today's video, we would like to learn about for loops in R programming language. Imagine that I would like to print numbers from 1 to 5. In order to do that, first of all, the first thing that I could do is to print them one by one. So print 1, print 2, print 3, print 4, and finally print 5. So I need to write down the print function 5 times. So when I want to print numbers from 1 to 5, it's easy to write 5 lines of code. However, if you would like to print numbers from 1 to 1000, it would be very difficult to do it manually. This is, in fact, why we do coding in the first place. So this is why we need to use coding and we need to develop a good code, an efficient code to do the work for us instead of us going through a very difficult journey like writing the print function 1000 times. Okay, so now for repetitive tasks like this, so printing numbers from 1 to 5, we can use for loops, meaning that we're going to write 2 lines of code instead of writing it thousands of times to do the work for us. For example, here I would like to print numbers from 1 to 5. I would like to use a for loop, meaning that I would like to have a loop that is going to iteratively get numbers from 1 to 5, and in each iteration it is going to print the value of the taken unit. Okay, for example, here I write down for loop, so I use the for keyword, and in parentheses I define my iterating variable, which is I. So for each I in the range between 1 and 5, so go and execute this part. Okay, print I in each iteration. So in the first iteration, I equals 1 because the range starts from 1. It prints number 1. Then in the next iteration, I equals 2, it prints number 2. Then next iteration, I equals 3, it prints number 3. Next iteration, I equals 4, it prints number 4. And finally, in the last iteration, I equals 5, so it prints number 5 in the output as we see it here. So we see that by defining a for loop and writing down the print function only one time, we get to print the numbers that we are looking for. So instead of 1 to 5, what if I want to have 1 to 50? So for that, I simply change the ending point. Okay, and I run the code one more time here, and you see that from 1 to 50 is being printed here. Okay, so in order to do repetitive tasks, it's better to use for loops. For example, here I wanted to print numbers from 1 to 50, in this case, in the last example. So I use the for loop. I have my iterating variable for each I that is in the range 1 to 50. So before colon, it's the starting point. After colon, it's the ending point. Okay. And for each I that is getting these values, perform this. Okay, print I. And in each iteration, we print the value of I, and we see that it goes exactly from 1 to 50 that we were looking for. Thanks for watching. Hello everybody, and welcome to this video. In today's video, we're going to learn how to print only even numbers between 1 and 10. In order to do that, we are going to write a for loop and one if condition. Why? Because we need a for loop to go through numbers from 1 to 10, and then we would like to have an if condition to categorize, let's say, the even numbers only, and print the even numbers only in the output. So this is my output, number 2, 4, 6, 8, and 10. So these are the even numbers between 1 and 10. In order to do that, first of all, we need to define a for loop. So for each I that is inside this range. Okay, so in order to write down a for loop, we use the for keyword, and I is my iterating variable here. Okay, so for each I that is in the range starting from 1 and ending at 10. Okay, we are going to have this for loop that is this part. But inside the for loop, we are having one if condition. This if condition says that if that I is divided by 2 and the remainder of their division using the modulus operator equals 0, then we realize that that number is an even number. This is a definition of an even number. Okay, print I for me. Okay. So first of all, in the first iteration, I gets the value of 1. 1 divided by 2, the remainder of this division. Is it 0? No. How do we know? How do we calculate it in the code? Simply, we are having 2 percentages signs, and it is going to calculate the remainder of a division for us automatically. So 1 divided by 2, their remainder equals 0? No, this statement is not true. Therefore, this part of the code is not going to be executed. And we go for the next iteration. Now I equals 2, because we are still in the for loop. Okay. So I equals 2, 2 divided by 2, the remainder of this division equals 0. Yes, it is equal 0, because 2 divided by 2, the remainder will be 0, because 2 is an even number. And therefore, we're going to print I equals 2. Which is being shown here in the output. Okay. Then in the next iteration, 3 divided by 2. So in the next iteration, I equals 3. 3 divided by 2. The remainder of this division equals 0. No, because it's an odd number. Therefore, nothing happens and we are not going to execute this line. We go to next line. So if we go for the next iteration, I equals 4, 4 divided by 2, the remainder equals 0. Yes, therefore print the value of 4 in the output. Okay, so this is going to continue as long as the I equals 10 in the last iteration. So this is the ending point. 10 divided by 2, the remainder of this division equals 0. Yes, therefore we are going to print the I equals 10 for the last time. So in the last iteration, we're going to print the value of I, which is I equals 10, okay, which I equals 10. So basically, in this video, we learned how to work with a for loop to go through numbers from 1 to 10. And then also we defined an if condition inside the for loop to print only the even numbers. And the definition of an even number is the following. If a number is divided by 2 and the remainder of their division equals 0, it means that that number is an even number, okay? So otherwise it's an odd number. And then if it was an even number, we were going to print it in the output. Thanks for watching. Hello everybody and welcome to this video. In today's video, we're going to work with another example of for loops. So first of all, I have a vector of names that is called C, okay? So C is a vector of names, and you see that inside parentheses, I have 3 names, Alice, Bob, and Charlie, okay? And this vector of names is being assigned to a variable called names. So names now is a vector of names, and it has 3. Hello everybody and welcome to this video. In today's video, we're going to have another example of for loops in R programming language. So first of all, we would like to define a vector of names, and then we are going to print the names that are inside that vector one by one. So here I have the vector of names being initialized. So the name of my vector is names. And here we are having 3 names in our vector, Alice, Bob, and Charlie, okay? And we are using the C function to combine values into a vector. So these are my values that are being combined into a vector, and they are being assigned using the assignment operator to names, okay? This is the name of my variable, name of my vector. So now I would like to print the names one by one. Alice, I would like to print it. I would like to print Bob, and I would like to print Charlie, okay? In order to do that, of course, we can do it manually, but we don't want to do that. It's not efficient. So we need to have a for loop. So we define a for loop for each name in names. So names is the name of my vector, and name is my iterating variable. It could be I, for example. Let me just put I here. It's easier. So this is my iterating variable for each I in the names vector. In each iteration, okay, print this, okay? And what is going to print is going to print hello, and then in the first iteration, I equals Alice, the first name in the names vector. So hello Alice in the next iteration, hello Bob in the next iteration, hello Charlie. So you see that here we have all of them in the output, hello Alice, hello Bob, and hello Charlie, okay? But what does this paste function do here? So if I remove the paste function, it's not going to work, and we're going to see errors. Why? Because we are having 2 strings here. So this is the first string, and this is the second string, and we would like to join them into one string. As you see here, a hello Alice is being printed as one string, but here they are separated. So I use the paste function to join multiple strings or variables together into one string, okay? And then we have the print function to print them in the output. So hello Alice, hello Bob, and hello Charlie. They are being printed in the output. So in this video, we learned how to define a vector of names, and we used the C function to combine values into a vector. And then we had a for loop for each I in the names vector. We are going to, in each iteration, print the elements of that vector. So I in the first iteration equals Alice, so we are going to have hello Alice. In the second iteration, I equals Bob, so we are going to have hello Bob. In the last iteration, I equals Charlie, so we are going to have hello Charlie. Thank you for watching. Hello everybody and welcome to this video. In today's video, we would like to print the square of each number from 1 to 5. So now that we see that we need to print the squares of numbers from 1 to 5, it means that we need to do a repetitive task. And a repetitive task requires a for loop. Okay. So in order to have a for loop, we simply write down the keyword for, and I is my iterating variable. So for each I in the range starting from 1 and ending at 5, because the problem statement was mentioning that, we're going to start from 1 and we're going to end at 5. Okay. We're going to execute this part of the code. For each I in this range, we're going to execute this part of the code. In the first iteration, for example, when I equals 1, we are going to raise 1 to the power of 2 and assign it to a variable called square. Okay, so in the first iteration, let me write it down here. The first iteration, I equals 1, and we are going to have 1 multiplied by 1, so the output is 1, and number 1 is assigned to a variable called square, and this is the assignment operator. In the next line, we are going to print this message. The square of 1 is, and we are going to print the value of the square variable which equals 1. So this is why we see it here. Square of 1 is 1. Okay. So we use the print function to have this part being printed in the output, and we use the paste function because we are having multiple strings and we would like to join them into one single string in the output. So square of 1 is 1. And then in the second iteration, I equals 2. Therefore, we are having 2 multiplied by 2. So the output is 4. So here, when I equals 2, we are having number 4 as we calculated here being assigned to a variable called square. And in the next line, we are printing this message. The square of 2 is 4. So square of 2 is 4. Then we go for the third iteration, which is this one. So I equals 3. So we are having 3 multiplied by 3. The output is 9. 9 is assigned to a square variable, so we see that square of 3 is 9. And then we are having the fourth iteration, I equals 4, so we have 4 multiplied by 4, so the output is 16, so we see that the square of 4 is 16. And finally, in the last iteration, we are going to have the I equals 5, meaning that 5 multiplied by 5, it's 25. So 25 is assigned to the variable square, and we are printing it here in the output. So square of 5 is 25. So in this video, we learned how to print the square of each number from 1 to 5. Thanks for watching. Hello everybody and welcome to this video. In today's video, we are going to discuss about while loops in our programming language. So here we are going to discuss while loops. Before we discussed about the for loops. However, while loops are going to be... Hello everybody and welcome to this video. In today's video, we are going to learn about while loops. So while loops are going to be used for different purposes. We can have loops like for loops, and we can have another type of loops that is while loops. Usually when we don't know how many times we're going to do the repetition, it's better to continue, better to implement actually the while loop. So now here I'm having an example here for you. I would like to write a program to have a countdown. So I would like to print numbers from 1 to 5. In order to do that, first of all, I need to initialize my iterating variable. So I is my iterating variable that is initialized to be 1 using this assignment operator. Okay. Then in order to actually implement a while loop, we are going to write down the while keyword, and inside parentheses we are going to write down the condition. So we would like to continue this while loop as long as I is less than or equal to 5. Okay, and when this condition is met, we are going to execute this part of the code actually. And whenever we are going to enter this while loop, first of all we are going to print I, and then we are going to increment the value of I by 1 unit. Let me illustrate it with an example. So here is my iterating variable I initialized to be 1 in the first iteration. So 1 is less than or equal to 5. Yes, it is true. So in the first iteration, first of all, in the first iteration, we are going to print 1. Okay, and then when I run the code, you see this output. So we are going to print 1, and in the next line we are going to increment the value of I by 1 unit. So I, it's like equals I plus 1. So I already is 1, and we are adding another 1 unit to it, so it will become 2, and 2 is assigned to be the new value of I. Okay, so we go up again, so we check this condition. Now I equals 2. 2 is less than or equal to 5. Yes, so we are going to, in the second iteration, we are going to have the print of number 2, and I equals I plus 1 again, and this time we are going to have 2 plus 1, which will be 3. So this part is finished. We go up for another iteration. 3 is less than 5. Yes, we are going to print 3, and then we are going to increment it by 1 unit, so it will become 4. And then 4 is less than 5. We are going to print 4, increment it by another 1 unit. It will become 5. 5 is less than or equal to 5. Yes. So we are going to print 5. We are going to increment by 1 unit. We are going to increment it by 1 unit. So it will become 6. 6. Is it less than 5? No. So this condition is not passed, and the program is terminated. And when we look at the output, we are going to see I is 1, 2, 3, 4, and 5. We also could change this condition. For example, we could have I equals 5, for example, and we change this condition. So we would like to continue as long as I is greater than or equal to 0. And in each iteration, we are going to reduce 1 unit from I. This way, it means that we are going to start with I equals 5. 5 is greater than 0. Yes. So we print 5. We reduce 1 unit. So it's 4. 4 is greater than 0. Print 4. It will become 3. 3 is greater than 0. Yes. So we print 3, and we are going to reduce it by another 1 unit. So it is going to continue as long as I equals until I equals 0. So this way we are going to have a countdown from 5 to 0. The previous example was to have a count up actually from 0 to 5. Now we are having a countdown from 5 to 0. So we see that here by changing some minor modification, by having some minor modification in the code, we can reach to a totally different program. Thanks for watching. Hello everybody and welcome to this video. In today's video we are going to discuss while loops. We're going to write a program to calculate the sum of first 10 natural numbers using a while loop. So in order to use a while loop, first of all we need to initialize our iterating variable, which is I, and it is initialized to be 1, and we are having a new variable called sum, and we are going to store the sum of the first natural numbers in this variable, and it is initialized to be 0 in the beginning, but we're going to update it in each iteration in our while loop. So here is my while loop. We're going to continue this while loop as long as I is less than or equal to 10. This is the condition of this while loop. And why this is the condition? The reason why is that we would like to calculate the sum of the first 10 natural numbers. If we wanted to have the calculation of the sum of the first 100 natural numbers, this condition should have been I less than or equal to 100 rather than 10. But this condition comes from the problem statement. Okay, so while I is less than or equal to 10, we're going to execute this part of the code. Okay, basically in each iteration, first of all, we are adding the value of I to the variable sum, and then we are going to increment the value of I by 1 unit. So let me illustrate it with an example. So in the first iteration, we're going to have I to be equal to 1, okay, meaning that sum equals sum plus 1, and sum is initialized to be 0 in the beginning. So the new value of sum is 1, sum equals 1, okay, and then we increment in this line the value of I. Okay, so the new value of I equals I plus 1, and I equals 1 plus 1, it will become, so I equals 2 now. Okay, so then we go for the second iteration. I equals 2. 2 is less than or equal to 10. Yes, so I equals 2. We're going to have sum equals 1 plus 2. Why? So this number 1 comes from the fact that we're going to have sum, the new value of sum equals sum plus I, okay, and the final version, the last version of the sum has the value of 1. So this is why we are having 1 here, and I equals 2 from the previous iteration, so we are having 2 here. So 1 plus 2, sum equals 3, and now I equals 3 as well. Okay, so in the third iteration, I equals 3, sum equals 3 plus 3, so sum will become like 6, and I now will become 4. Okay, so then we are having the fourth iteration where we are having I equals 4, so sum equals 6 plus 4, so sum equals 10, and I equals 5 this time. So this iteration is going to continue until we reach I equals 10. Then at that point we are going to have the final value of sum, because in each iteration the sum is being updated. So let me illustrate it with an example. In the first iteration, sum will become 1. Why? Because I equals 1. Okay, I equals 1, sum will become 1. In the second iteration, I equals 2, and sum will become 3, because 2 plus 1, which is the value of the previous iteration of sum, will become 3, because we are trying to have the calculation of the sum of the natural numbers from 1 to 10. So now we added 1 and 2. In the next iteration, I equals 3 here, as you see. Then we are having the new value of sum equals to 6, meaning that the previous value of sum, which was 3 in the previous iteration, plus the current value of I, which is number 3, it will become 6. So this way we are adding the values of I to a new variable called sum. So first of all, we are adding number 1, we store the value. Then we add on number 2, then we add on number 3, then we add on number 4, and it is going to continue until the last iteration where we add on number 10 to the value of sum. So from number 1 to 10, the sum when we run the code will become number 55 following this logic. But if we want to do it with hand manually, it's very hard. But using this code, it's very easy now to even calculate the sum of numbers from 1 to 100. So when I run the code now, because I modified 10 to 100, it will become 5050. The sum of numbers from 1 to 100. Thanks for watching. Hello everybody and welcome to this video. In today's video, we're going to write a program to print even numbers from 2 to 10 using a while loop. So in order to do that, first of all, we need to have the initialization of our iterating variable, which is I, and number 2 is assigned to it. So because we would like to have the print of even numbers from 2 to 10, this is why the starting point is 2, and we are going to assign number 2 to the variable I. Then we are having a while loop, and this is the condition of our while loop. So this while loop is going to continue until I is less than or equal to 10. Because the ending point is 10, this is why we are going to continue this while loop as long as I is less than or equal to 10. And then we are going to have this part of the code being executed when this condition is passed. Okay, so we are going to have the print of I in the first iteration. Then we are going to increment its value by 2 units. Why by 2 units? Because even numbers are going to be 2, 4, 6, 8, and 10. So there are differences between 2 even numbers that are 2, not 1. Because if we add 2 plus 1, if we add 1 plus 2, it will become 3, which is an odd number. It's not an even number. So in order to get another even number starting from number 2, we need to add 2 units in each iteration. Okay. So when I run this code, we see that 2, 4, 6, 8, and 10. These are the numbers that are being printed in the output. So these are the numbers that are being printed in the output that are even numbers from 2 to 10, as we expected. But how does it work? So let me illustrate it here with details. So in the first iteration, I equals 2. So we're going to print number 2. Okay. And then increment the I variable by 2 units. So I will become 4. Then in the second iteration, we are going to have I equals 4. So we print 4, we increment it by 2 units, it will become 6. Then in the third iteration, we are going to have I equals 6. So we print the 6, and we're going to have I equals 8 now. Okay, we increment it by 2 units. So and finally in the last iteration, which is the fourth iteration, we're going to have I equals 8. So we print 8. Therefore I now equals 10. Okay, and sorry, it was not the last iteration. The fifth iteration is the last iteration. So the fifth iteration, we're going to have I equals 5. Then we're going to print number 10. Increment the value of I by 2 units, so it will become 12. But we're not going to continue this while loop. Why? Because now I equals 12. So 12, is it less than 10? No, it's not going to pass this condition. So we're not going to have another iteration. Okay. So in this video, we learned how to have a while loop to print even numbers from 2 to 10. Thanks for watching. Hello everybody and welcome to this video. In this video, we are going to demonstrate the use of break statement in a while loop. So here we are having one variable called I, and it is initialized to be 1. And we are having one while loop that the condition is true, meaning that it's an infinite while loop. And if we don't put a break statement, this condition will be always stay true because there is no condition actually there. This is just a true statement in parentheses. So when we are having the true statement in parentheses, we should have a break statement. Otherwise, it will become an infinite loop. Okay, so now I have the condition, the statement, the while loop statement or condition to be true all the time. And for certain situation, I'm going to put the break. So at some point, this program is going to be terminated. And first of all, what I'm going to do is that when we enter this while loop, first of all, I'm going to print the value of I in each iteration. Okay. And if I equals 3, I'm going to break, meaning that I'm going to terminate the while loop using the break statement. It's that simple. Otherwise, if this condition is not true, this part is not going to be executed and this line is executed. So the value of I is going to be incremented by 1 value. So let me illustrate it with more detail. So first iteration, I equals 1. Okay. So the condition is true. So we're going to enter the while loop. So we print value 1, which is here. You see it here. And we check 1 equals 3. No. So we are not going to enter this part. We're going to increment the value of I. So I now equals 2. Okay. So I now equals 2. So in the second iteration, we're going to have I equals 2. We're going to print 2 that we see here in the output. And then we check to see if 2 equals 3. Is it true? No. So this part is again not executed. We're going to increment the value of I. So I becomes 3. I equals 3 now. So then we are going to have the third iteration. So I equals 3. We're going to print the value of 3 here. And this loop is going to be continued. Why? Because the condition is always true. So we are going to have the print of I equals 3. So we see number 3 here in the output and we check this if condition. 3 equals 3. Yes, this time it's true. So we mentioned that if I equals 3, then break. Okay, meaning that exit the loop when I equals 3. So this break is executed. Therefore, this part of the code is not going to be done anymore. So this increment is not going to be done anymore and the program is terminated. So this is why we are having 1, 2, 3 only in the output. So if I write down instead of 3 number 10 here, it means that we're going to print 1 to 10, but we're not going to have the number 11. Why? Because when we print the I equals 10 here, then 10 equals 10, this condition is met. We're going to break and we're going to exit the loop when I equals 10 now. And this part is never executed anymore to increment the value of I from 10 to 11. So now if I run the code, you see that the print of from 1 to 10 is being shown here in the output. Thanks for watching. Hello everybody and welcome to this video. In today's video, we're going to learn how to create a numeric vector in R. In order to create a numeric vector, simply on the left hand side, we write down the name of the vector. Okay, so in this case, I chose to have a vector with the name numbers. Then on the right hand side, we simply use the C, and inside parentheses, we put the numbers that we would like to be inside our vectors. This way, these 5 elements are assigned to a vector called numbers. And then when I print this numbers vector, I see those elements in the output. So if I want to have, for example, a vector with 8 values, so now if I run the code one more time, I see that I have 8 numbers in the output. So this is basically a simple example of how to create a vector, a numeric vector, let's say, that is called numbers. And we can have another one that is, for example, called my vector. Simply, this is the assignment operator. And then I use a C and then whatever I want. So 20, 10, 52, 5, 4, 87, for example. Okay, so this is my vector. And this is the vector that I just created called my vector, let's say, with the elements that are 20, 10, 52, 4, and 87. And then I use the print function to print the vector that I just created that is called my vector. And when I run the code one more time, I see the elements of the second vector that is called my vector in the output as well. Thanks for watching. Hello everybody, welcome to this video. In today's video, we are going to learn how to access elements of a vector in R programming language. So first of all, this is my vector called fruits, and we see that these are the elements that are assigned to this vector fruits. So apple, banana, and cherry. These are the three elements that are assigned to my vector that is called fruits, okay? And we know that when we want to declare a vector, we need to have the C function, or let's say keyword, and inside parentheses, we write down the elements that we are looking for. And these are the elements actually that we want to be assigned to the vector. And each element is separated by a comma from the other one. And because these are the elements that are string, they are in the quotes, you see. So this is why we're having the quotes here. If it was just numerical vector, we could simply write down the numbers, okay? Now I would like to access only one element of this vector, and I would like to access this banana, which is the second element, in fact, okay? So in order to access that, we simply write down the name of the vector and then the index of that element that we are looking for, which is 2, because banana is the second element and I'm looking for the second element of the fruits vector. Therefore, I use the print function. So when I run this code, I see banana in the output. But if I want to have the access to the first element of the vector fruits, so when I put number 1 as the index of this one, I run the code one more time, so apple is being shown. So the number of index of the element, we need to write it down inside the parentheses, let's say the square brackets, and then it's going to call that specific element, okay? And if we want to print the whole vector, we know that we simply need to call the fruits vector inside the print function. So this is why now we see the vector, the full elements of a vector in the output. Also, if I want to have another numeric vector, for example, just to clarify this point, we use the C, and then inside parentheses we write down 2, 5, 3, 8, for example. So each element is separated by a comma from the other one, but because they are numeric values, we simply write down the numbers. And here we were having the quotes because there we were having strings as the elements. So this is how it works. When you're having strings as elements, you need the quotes as well. Thank you for watching. Hello everybody, and welcome to this video. In today's video, we are willing to write a program that modifies one element of a vector. So first of all, we are having our vector called scores. And then these are the elements of this vector 10, 20, and 30 that are assigned to a vector called scores, okay? So first of all, I'm going to print scores vector. So when I run this code now, you see 10, 20, and 30 in the output, exactly the elements that are assigned to scores vector, okay? But I would like to modify the first element of this scores, let's say, vector. So the first element has the numeric, is actually a numeric integer that is 10. Now I would like to modify it and put it to be 15. In order to do that, we simply write down the index of the element in the scores vector on the left hand side, and then number 15, for example, on the right hand side. So it's going to change the first element in the scores vector, and 15 is going to be assigned to the first element of the scores vector, and which is now number 10, okay? So when we do that, and then if I print the scores vector one more time, we see that now it has 15, 20, and 30 instead of 10, 20, and 30, okay? So basically this is how we can modify an element of a vector. But what if I want to modify the second element? So now I would like to modify the second element, and I want the second element to be, for example, 33. So now I run the code. I see that the first element remains unchanged, and the second element is now 33. The third element also remained unchanged. So we write down number 33 on the right hand side. It is going to be assigned to the second element of the scores vector. And when we reprint the vector one more time, we see that the modified version is out there. Thanks for watching. Hey everybody, and welcome back. In today's video, we would like to perform some mathematical operations using vectors. In this video, we learn how to declare two vectors and how to perform mathematical operations like element-wise addition, subtraction, multiplication, or division between these two vectors and assign them to a new vector called result. So here is my first vector that is called A, and these are the elements of the vector A. So 1, 2, 3 is assigned to a vector called A. Numbers 10, 20, and 30 are assigned to a vector called B, and then these two vectors that are now declared A and B, I would like to have the element-wise addition of them, okay? And the element-wise addition means that the first element of the vector A is going to be added to the first element of vector B. The second element of vector A is added to the second element of vector B. The third element of vector A is going to be assigned to the third element of vector B, okay? And all of them are going to be assigned to a vector called result. Then we print the result vector, which is 11, 22, and 33. So 11 comes from where? So 1 plus 10, it's 11, is the first element of the result vector. Then we are having 2 plus 20, which is 22. So 2 plus 20 is 22, the second element, and 3 plus 30, it will be 33. So it's the third element. So this is how basically we can have the element-wise addition of two vectors. But if we, instead of having the plus, if we are having the negative sign, we're going to have the element-wise subtraction. So if I run the code one more time, we see that 1 minus 10, it will be negative 9, 2 minus 20, negative 18, and 3 minus 30, it's negative 27. So it's element-wise subtraction. Then we can have the element-wise multiplication here. So when I run the code now, we are going to have 10, 40, and 90. So 1 multiplied by 10, it's 10. 2 multiplied by 20, it's 40. And 3 multiplied by 30, it's 90. And finally, if we want to have the element-wise division, we simply have A divided by B there. So we run the code and we see that all the elements are going to be 0.1. Okay, so this is basically how we can have element-wise mathematical operations. Thanks for watching. Hey everybody, welcome to this video. In today's video, we would like to learn how to filter one vector in our programming language. So we can filter them with a condition, in fact. In this video, we learn how to filter a vector with a condition indeed. So here on the left hand side, the name of my vector, my original vector is x, and these are 4 elements of this vector, 5, 10, 15, and 20. So these 4 elements are assigned to a vector that is called x. Now I would like to filter based on one condition. And the condition is that I would like to keep all the elements that are greater than number 10. Okay, so I would like to keep only the elements that are greater than 10 in the x vector, and then assign them to a new vector called filtered, and then print the filtered vector. In order to do that, simply I write down for vector x, each x, meaning that each element that is greater than 10, then that is going to be assigned to a vector that is called filtered. Okay, so it means that, for example, in this one is the name of the vector, and this in the square bracket we are having the indices, meaning that here the element if of the x vector. Okay, if that element if is greater than 10, assign it to the filtered vector. If not, don't assign it, go for the next element. Okay, so number 5, is it greater than 10? No, we're not going to assign it. 10, is it greater than 10? No, because we are looking for numbers that are greater than 10, not greater or equal. Okay, only greater than and equal. If we were having that, 10 would have been included, but because we're having only greater than, so 10, is it greater than 10? No, they're equal. They're not, it's not greater than the other one, therefore we're not going to assign that. So 15, is it greater than 10? Yes, it is going to be assigned to the filtered vector. 20, is it greater than 10? Yes, it's greater than 10, so we're going to assign it to the vector called filtered, and then we are going to print the filtered vector in the output. So 15 and 20, both of them are being printed in the output. So what if I change this condition? So I would like to print only the I would like to assign only the elements that are greater than 16 and assign them to the filtered vector. So when I run the code, I see only the number 20 in the output, because this is the only element of the vector x that is greater than 16. Then this is the only element that is assigned to the filtered vector. So what if I change this? I put it 10, and now I have the greater than or equal to. Okay, so now 5, is it greater than or equal to 10? No. 10, is it greater than or equal to 10? Yes, so 10 is also assigned, then 15, and then 20. So basically this is how we can have the filtration of a vector with a condition. Thanks for watching. Hello everybody, and welcome to this video. In today's video we're going to learn how to create an array in R programming language. So first of all, I need to name my array. I call it R1. I could name it, for example, X. So I'll call it X. X is my array. Then in order to create an array, simply on the right hand side, I call the array function, and then I mention in parentheses starting point, colon, the ending point. Okay, so it will be the 1 will be the starting point of our array. Then we will have number 5 as the ending point of our array. Okay, so number 1 to 5, they are being assigned to our array called X, and then we're printing the values that are inside the array X. So we are having 1 to 5 in the output. So in case I want to have from 1 to 15, so I change this and I run the code one more time, and then we see in the output we are having from 1 to 15 in the output. So this is basically how we can create an array in R. Thanks for watching. Hello everybody, and welcome to this video. In today's video we're going to learn how to create a two-dimensional array in R. So my array's name is X. We are having the X on the left hand side. On the right hand side I call the array function, and this is what happens inside the parentheses. So we are having two parts that they are being separated by a comma. So starting point is 1 and the ending point is 6. And then on the after comma part, we are going to have the dimensions. We are going to tell the compiler to have the dimensions equal to C, 2 and 3, meaning that I would like to have 2 rows, okay, and 3 columns. So numbers from 1 to 6 should be divided into 2 rows and 3 columns. Okay, so when 2 multiplied by 3, it will be 6. So 6 values make sense to have for our array. So when I print the array X, we see that this is the first row, this is the second row as we expected here, and then we are having 3 columns. So this is the first column, second column, and the third column. And we see that numbers are from 1, 2, 3, 4, 5, and 6. So what if I want to have 3 rows and 3 columns? Would it be possible to have it from these numbers? No, because when we are having 3 rows and 3 columns, we need to have 9 elements, while we are having only 6 elements here. So I changed the ending point and I put it to be 9. So when I run the code, we see that 1, 2, 3, 4, 5, 6, 7, 8, and 9. Previously, we were having up until 6, so the last column would have been empty. But if we want to have some values, we need to put the starting point and ending point in accordance with the number of rows and columns. So this is the first row, this is the first row, second row, and the third row, and this is the first column, second column, and the third column. Thanks for watching. Hello everybody and welcome to this video. In today's video, we are going to learn how to have the sum of values inside an array in our programming language. So the array name is R. I call it X for the sake of simplicity. So this array is having numbers from 1 to 9 and it has 3 rows and 3 columns. Okay. So an array is created with 3 rows and 3 columns with numbers from 1 to 9. So first of all, let me print the value of X. So when I run the code, this is the value of X. This is my array. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So these are the values. Okay, now I want to calculate the sum of all the values that are inside this array. Meaning that I would like to have 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9. What would be the output? The output will be 45. But how can we calculate it in code, actually using codes, not doing it manually? In order to do that, I call the sum function for the X array. So inside parentheses, we write down the name of our array. Okay. So the compiler is going to calculate the sum of all the elements that are inside the X array, and it is going to be assigned to a variable called total. And then I print this total variable, which is 45. So this is basically how we can calculate the sum of all the elements in an array. So if I change the dimensions also, so if I have, for example, 2 rows and 3 columns and the starting point is from 1 to 6. Now if I run the code, firstly we see that the array is being modified, so we are having 2 rows and 3 columns, and also we are going to see that the sum is 21 because we are having only from 1 to 6. Thanks for watching. Hello everybody and welcome to this video. In today's video we're going to learn how to create an array with strings. So the name of my array is X, as we see it on the left hand side, and then in order to create our array we simply call the array function, and then we are having the strings. So this array this array has 4 elements, so Alice, Bob, Charlie, and Donna. So these are the 4 names that I would like to be assigned to our array called X, which is an array of strings. And then I would like to know its dimension. So the dimension is 2 by 2. So we are having 2 rows and 2 columns. Okay. So after creating the array X, I print the array X. So when I run this code, we see that here the names are being printed: Alice, Bob, Charlie, and Dana. If I want to have, for example, 2 rows and 3 columns, we can also do that, but we need to add a few names, like 2 names there. Why? Because when we are having the 2 rows and 3 columns, 2 multiplied by 3 will be 6, meaning that we need to have 6 names, while we were having only 4 names. So I add 2 names, Reza and Shaheen, and I run the code one more time. So we see that now we are having 2 rows and 3 columns, column 1, column 2, and column 3. And we see that Reza and Shaheen, both of them are being added to this array of strings in R. Thanks for watching. Hello everybody and welcome to this video. In today's video, we are going to learn how to have an array being multiplied by a constant number. So first of all, I have an array that is called X. To create this array, I call the array function. The starting point and ending point, they are 1 and 6. So we're going to start from 1 and then we're going to finish at 6. And the dimensions are 2 and 3. So we are having 2 rows and 3 columns. Okay, so this is the way that I am organizing the array. So now when I run this code and I print the array X, we see array X is this one. So we are having 2 rows, as you see, and 3 columns, 1, 2, 3, 4, 5, and 6. So these are the elements of the array. Then I would like to multiply the elements of this array by a constant number, which is integer 10. Okay, so I write down the name of the array multiplied by 10, and it is going to be assigned to an array called result, and then I print the result array. So we see that here in the output, we are having now 10, 20, 30, 40, and 50, and 60. So the original elements of the original array X, they are being multiplied by 10. So this is why instead of 1, we are having 10, instead of 2, we are having 20, instead of 3, we are having 30, etc. until the end. We could have another constant. For example, I could have number 5. So when I run the code, we see that here we are having the elements multiplied by 5, for example, here. Or we could have the addition also. So element-wise addition, meaning that each element in the array X is going to be added by 5. So instead of having 1, now I'm having 6. Instead of having 2, I'm having 7. Instead of 3, I'm having 8, etc. until the end. So this is basically how we can have the element-wise mathematical operations in R. Thanks for watching. Hello everybody and welcome to this video. In today's video, we're going to learn how to have sum of each row in an array and also sum of each column in an array. So this is my array called X. I'm creating it and starting from 1 and ending at 9. And then the dimensions are 3 by 3, meaning that 3 rows and 3 columns. So when I run this code, you see the original array X is being printed using this line in the output. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. So these are the elements of our array X. Okay. Now I would like to have the sum of each row, meaning that I would like to have the sum of these 3 numbers and these 3 numbers and these 3 numbers. And then I would like to have the sum of each column, meaning that I would like to have 1, 2, 3, the sum of 4, 5, 6, the sum of 7, 8, and 9. But how can we do that? In order to do that, I have the apply function for the X array with the margin 1 and call the sum function because we would like to calculate the sum. When we are putting the margin to be equal to 1, it means that we want to have the sum of each row, margin equals 1, for the X array using the apply function. It is being assigned to a new array, let's say with 1 row, that is called row sums, and we print row sums. So we see that 12, 15, and 18 is being printed in the output. So 12 actually comes from the 1 plus 4 plus 7. 15 actually comes from the fact that we are adding 2 plus 5 plus 8. So this is the second row sum. And 3 plus 6 plus 9, it is going to be printed in 18 here. It is going to be shown as 18 here. So 18 is the sum of these 3 elements. Okay, so this is the sum of each row. Now I would like to calculate the sum of each column. Again, I call the apply function for the X array. Use the sum function for margin equals 2, meaning that I would like to have the sum of each column for the X array using the apply function. It is going to be assigned to call sums and we are printing it in the output. So we see 6, 15, and 12, 24. So 6 comes from 1 plus 2 plus 3. 15 comes from 4 plus 5 plus 6, and 24 comes from 7, 8, and 9. Basically, this is how we can have the sum of each row and sum of each column. Thanks for watching. Hello everybody and welcome to this video. In today's video, we would like to learn how to change a specific value in a two-dimensional array using in R programming language actually. So first of all, I need to initialize my array. My array is called X. I call the array function starting from number 1 ending at number 9. So starting point is 1 and ending point is 9. And the dimensions are 3 rows and 3 columns. Then I print the array X. Okay. So when I print this array, you see 1, 2, 3, 4, 5, 6, 7, 8, and 9. So starting from 1 ending at 9. We're having 3 rows and 3 columns as we specified here. Okay, so this is the number. Now I would like to modify a specific element in this array X. Which one? So I would like to modify the number that has this address, row 2, column 3. So this is the row 2, this is the row 2, and this is the column 3. So number 8, I would like to modify it. Okay. So if I want to modify number 8, firstly, I need to write down the name of the array, which is X, and then the address of that element, meaning that that element is in which row and which column. Then on the right hand side, I simply write down the value that I would like to be there instead of 8. So now I want to replace 8 with 99. So I put 99 on the right hand side. On the left hand side, I write down the address of that element in the X array and use the assignment operator. Then I use the print function to print the array X to see if everything is okay or not, if we did the modification or not. Looking at the output here, we see that 1, 2, 3, 4, 5, 6, and 7 instead of 8, we are having 99 now, and then number 9. So basically in this video, we learned how to modify that. So instead of 99, I could have 90, for example. I run the code one more time. We see that now the modified 8 is 90. But what if I want to modify number 5 and not number 8? So firstly, what is the value that I want to be assigned to number 5? Instead of 5, I would like to have number, for example, 50. Okay. Now I need to give the address of number 5. So it's in the row 2 and column 2. Okay. So row 2 and column 2 of the X array. Okay. 50 is being assigned to the element in the X array with row 2 and column 2. So if I run the code now, we see that the modified element is there actually. So we don't have the 8 being modified anymore because we didn't do it. But we see that instead of number 5, we are having number 50 as we were expecting it here. Thanks for watching.